Hey, this is Coach Reeves, and today we're going to continue factoring, except today's factoring is going to be special cases. Things are a little bit different. We've done trinomials in the last time. These are going to be a little bit different types of situation that you have to understand how to factor. But remember, always see if you can take out a greatest common factor first. You always have to try to do that first. All right, before we get started, look at this first section. It says we're going to try to find the difference of two squares. What are squares? That's when you multiply something times itself. And you know that, but we're going to hope that you have memorized these perfect squares. Look, if I have 1 through 12, it would be nice if you had learned along the way that 1 times 1 is 1, 2 times 2 is 4, you have learned your perfect squares. That way, if you have memorized those perfect squares, when they show up over here and they ask you, you see a situation and you say, hey, 36, I know that's a square, that's 6 times 6. Or if I see 121, I know that that's 11 times 11. So you don't have to memorize everything. It would be nice if you knew up to 12 times 12. That would really help you out if you knew it. That way you wouldn't have to spend so much time working with your calculator or maybe doing stuff by hand. All right, so let's watch this. Question number 1. It says the difference of two squares. The difference, when we're talking about in algebra and math, the difference means we're going to have a subtraction sign. Okay? And now you need to count. Remember how yesterday I asked you to count if you had a trinomial, and a couple of problems we had 4 terms. We had 1, 2, 3, 4 terms, and we had to use grouping. All right, so in this situation, we only have 2 terms. You need to pay attention to what we have. And then when you have 2 terms, I need you to start looking at the exponents. Because sometimes you can take out a greatest common factor, sometimes it will be a square, like this is r squared, and some problems we'll do today will have a 3, a cube, and we're going to learn how to factor something that is raised to the 3rd power. All right, so this is the difference of 2 squares. It tells you in the sequence, all right, the difference of 2 squares. Just like what we did with the trinomial, I'm going to ask you to look at the back sign. You're going to look and you're going to say, what do you mean the back sign? There's only one sign. Well, if there's only one sign, then it's got to be the back sign. True? We said if this back sign was negative, that tells me that my signs in my parentheses are going to be different. So when we're going to factor this into 2 parentheses, we know that this is going to make the signs different. Somebody has to be positive, somebody has to be negative. And now we can break this down. It was pretty easy the other day. We broke down, and r squared would be r times r. That's not tough. But now we're going to break down to 16. This is where I would hope that you could remember your perfect squares. Because what times what is 16? Hopefully you know that 4 times 4 is 16. Now, why does this come out this way? Because if we went back and we went ahead and multiplied or FOILed or boxed, we would get this. When we multiplied, we would get r times r is r squared. R times negative 4 is a negative 4r. 4 times r is a positive 4r. 4 times a negative 4 is negative 16. But look what happens in these middle terms. You have a negative 4 and a positive 4. These would cancel each other out. That's why we're left with r squared minus 16. So one has to be plus, one has to be minus, so when we can cancel these out. Got it? So again, this is the difference of 2 squares, meaning your signs are going to be different, okay? And then you try to break down the back end, the last term, as the same number. Okay, let's go to another problem. Look at this, my front term. I have 16x squared. I have 2 terms. What I'm thinking of, could this be the difference of 2 squares or the difference of 2 cubes? Because the difference of 2 cubes is what we're going to do in just a few minutes. Always check out your exponent, okay? Now there's not a greatest common factor, but we look at that exponent and that says square. So I think in my mind, is this the difference of 2 squares? I see the minus sign. I know it's the difference, but is this a square? Yes. 16 is a square. It's 4 times 4. Is this a square? Yes, it is x times x. Is this a square? Yes, it is 3 times 3. So this is the difference of two squares. So we know that this is a negative, so our signs are going to be different. So our parentheses, somebody has to be positive, somebody has to be negative. We break down the 16. The 16 is in the front half. So when we break down the 16, the 4s go in the front half. The x squared is in the front half. So when we break down x squared as x times x, it stays in the front half. The minus 9, the 9 is in the back half. So when we break that down, that will be 3 times 3. That goes in the second half or the back half of the parentheses. And this is how you factor the difference of two squares. Remember, we're always checking for a greatest common factor. We're also always looking at this exponent. Okay, you'll understand in just a second when we get to these other types of problems. All right, next problem. These are called perfect squares. Okay, perfect squares, I'm kind of goofy the way this is, but I'm going to say that my parentheses are going to be perfectly identical. The parentheses are going to be exactly the same. Notice what we just did. When we worked these problems, one was plus, one was minus. They're not exactly the same. One was plus, one was minus. They look similar, but they're not identical. So when we go here and when we have perfect squares, they're going to look exactly the same. Okay? So we look at this and we try to figure this out. We have three terms. Is there a greatest common factor? No, there's not a number or a variable in common. So we can factor this. There's two ways to do this. If you can recognize your squares, that would be great. It would make it a lot easier. But I'm going to show you, if you recognize your squares, how to do it. I'm going to show you, Coach, I never saw that. I didn't know that those were squares. So watch how we do this. This tells you the signs are going to be the same. This says they're both going to be minus. So we set up our parentheses. They're both going to be minus. We're going to look at this and we're going to break down to 25. What times what is 25? We're going to try and see if this works. We're going to say, hey, I think that's 5 times 5. And then we're going to try to break down the n squared. And the n squared is going to be n times n. And then we're going to try to break down this 16. This 16 is what? 4 times 4. Have we done this right? I'm not sure. Is there a way to check? Yes. Here's the way we're going to check. I'm going to ask you to multiply or pinch that in the middle, and I'm going to go negative 4 times 5n is a negative 20n. Then we're going to pinch in the back end. We're going to multiply. And we're going to say 5n times negative 4 is a negative 20n. That will give me a total of negative 40n. Is that what I needed to happen? Yes. So there's a quick way. If you recognize these as squares, so most of the time it'll be okay, but you need to check and make sure. So how do you check? You multiply, you pinch it in the middle and multiply. You pinch the back edges, or front and back edge, and you multiply, and you see what your total is to make sure that that's what you had at the beginning. And you're saying, all right, Coach, I don't know my perfect squares. I don't know what to do. Then you work it like we did on the last worksheet. Okay? Let's say that we're going to go to the box method. All right? So we go to the box. And we put 25x, or n squared, 25 n squared, just like last time when we did the box method. We put the positive 16 in this box. And then we multiply these together. 25 times 16 is a positive 400. Since that's a positive 400, we're going to add to find our combination. Now we're going to look for numbers that when you multiply them together, when you multiply you get 400, but when you add them, you need to get 40. So what can work? Well, you remember, you could put this in your calculator. Remember how we talked about it? You could go y equals 400 divided by x, and then go Control T. You remember how we said we could do that? Okay? So we could do that if you need to. But to make a long story short, this turns out to be 20 times 20. 20 times 20 is 400. 20 plus 20 is 40. That's what we want to choose. So we'll put a 20 in here. We'll put a 20 in there. We're going to look for what they have in common. Coming across, what number goes into both of these? The number 5 goes into both of those. They also have the letter N in common. Coming across the bottom, what number goes into both of those? It turns out the number 4 goes into both of those. 4 goes into 20, 4 goes into 16. When you go up and down, it's the exact same combination. What number goes in between into 25 and 20? 5. And they have the letter N in common. What number goes into 20 and 16? The number 4. And there's your numbers or your terms that you fill in. And so you would come over and you would say 5n minus 4, because we know the signs are the same. 5n minus 4. So either way, this is how you could factor it. But this is what's special about this, is they would ask you, they're going to ask you to write this as one parenthesis. 5n minus 4 squared. Because whenever you multiply something by itself, that's the same thing as squaring it. So they're going to expect you to write it like this. 5n minus 4 parentheses squared. Okay, let's try another one. All right, so we're going to try to take out a greatest common. We always try to see if we can take out a greatest common factor. In this case, I'm looking at it and I think the number 3. Because I think the 3 goes here, I know it goes here, I know it goes here, so we're going to try the number 3. So we factor out the 3. 27 divided by 3 is 9k squared. 36 divided by 3 is 12k. 12 divided by 3 is 4. Factored out, taken out the greatest common factor. Now look what we have left. Okay? Is it possible to continue factoring? Look what I have. Shouldn't do that. Look what I have. I have a 9. Is 9 a perfect square? Yes. Is k squared a perfect square? Yes. Now look at the back end. Is 4 a perfect square? Yes. So this could be perfect squares. So we're going to try. We're going to say 3. And we're going to say 2 parentheses. We're going to look at the back sign. That back sign right there is a plus sign. So that tells me my signs are the same. This says they're both going to be pluses. I try to break down to 9. What times what is 9? We're going to say 3 times 3 is 9. What times what is k squared? That's easy. We're going to break that down as the k times k. Now to go to the 4. What times what is 4? 2 times 2. I think I did a good job, but I'm going to check. We're going to make sure. I'm going to pinch this right here. I'm going to say 2 times 3k is 6k. I'm going to say 3 times 2 is another 6k. When I add these together, I get 12k. Yes, I've done a good job. Now, is there another way that I can write this? Yes. They said that we can write this as 3 parentheses 3k plus 2 parentheses squared, because there's 2 of them. It's this parentheses times that parentheses. Got it? Those are what's called a perfect square. Keep going. Now we're going to get the sum or difference of 2 cubes. The sum or difference of 2 cubes. It would be nice if you knew your cubes. All right? It would really help if you could know this in your hand. And I'm not going to ask you to memorize a whole bunch of them, but we know that 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. We need to get to where we maybe could know 6 times 6 times 6 is 216. 36 times 6. Okay? If you could know the first 6, that would help you out a bunch as far as recognizing, oh wait, I remember that's a perfect cube. So we can do it that way. All right, so here's our problem. I have 125 plus 27x to the third. So I'm going to ask you, hey, is this the sum of 2 cubes? I'm not sure. I see the x to the third. I'm thinking it's cubes, but I don't know about 125. So I'm going to show you to go to your calculator. And I want you to look at this. To the right of the number 9. Here's the number 9. To the right of the number 9, you push that button and it gives you a whole lot of choices. Okay? This fourth choice right here. I'm going to press that. I'm going to put a 3 here because I'm going to take the cube root. I'm going to put a 3 right there, and then I'm going to cursor to where I'm inside here, and I'm going to put in 125. And then I'm going to hit enter. And it turns out that the cube root of 125 is 5. That's the quick way to tell, if you don't know your cube roots, to take the cube root of a number. How did I do this again? To the right of the number 9, to the right of the number 9, this little square root, but it's not a square root, it's a radical symbol. It's a radical symbol that allows you to change the root or put in your different root. That's where you want to go. Okay? So we'll go back to our problems. And we're looking at it, and we found out that yes, this is a cube root. Over here we know that 27 is a cube root, and we know that x to the third is a cube. Why? Because x times x times x will give me x to the third. So here's how you do this if you have the sum or difference of 2 cubes. In the first parentheses, I'm going to ask you to take the cube root. In this first parenthesis, I'm going to ask you to take the cube root. What is the cube root of 125? And you would tell me it is a 5. And then I'm going to ask you to take the cube root of 27. And you're going to say the cube root of 27 is 3. And then I'm going to ask you to take the cube root of x to the third. X to the third. X times x. The cube root is x. That is the cube root. Okay? And here's the pattern I'm going to ask you to memorize. I think this is the easiest way. Over the years, this has worked out from all of my students for the most part. How do you memorize what to do now? In this next parentheses, I'm going to ask you to do this pattern. I'm going to ask you to square this first term. That's a square. I'm going to ask you to square the first term. What is 5 times 5? 25. So we have squared the first term, 25. Then I'm going to ask you to do this. That means to change the sign. What is the sign right here? That's a plus. So we're going to change the sign. Okay? Then I'm going to ask you to multiply. That means to multiply. And we're going to say 5 times 3x. And you're going to say, wait, coach, 5 times 3x. That's a positive 15x. I get it. But I've already told you that we have to change the sign. We have to change the sign. Okay? So then let's go back there. We have to multiply. 5 times 3x is 15x. And then I'm going to ask you to square it again. What is 3x times 3x? And this is the tough part. This is the scary part. Because you have to square the number and you have to square the variable. What is 3 times 3? That's a positive 9. What is x times x? X squared. This is how you factor the difference of 2 cubes. You have to take the cube roots, and then you're going to follow this pattern. This is the easiest way I can do it with these little symbols. Okay? It has really helped my students. If you write these symbols and you memorize them, it's going to tell you what to do, because you're going to square the first term, you're going to change this sign, you're going to multiply these two terms together, and then you're going to square the back term. It works every time. Okay? Let's go to another problem. Now we have a difference. This is the difference of two cubes. Okay? Is 16 a cube? Oh, 16 is not a cube, coach. But have we tried to take out the greatest common factor yet? Always, always, always. Is there a number that goes into both of these? And yes, the number 2 goes into both of those. So we factor out our greatest common factor, and I get 16 divided by 2 is 8, x to the third, minus the 2's will cancel, and that leaves me with y to the third. Uh-oh. What do we do when there's two variables? Take a deep breath. It's easy. Because where did x to the third came from? X to the third came from x times x times x. Where does y to the third come from? Y times y times y. So it's not that big of a deal, even though they're variables. All right? So we bring down our 2. Please don't forget about the 2. And in the first parentheses, remember, we're going to ask you to write the cube root, or to find the cube root. What is the cube root of 8? 2 times 2 times... The cube root of 8 is 2. What is the cube root of x to the third? X. Bring down your minus sign. What is the cube root of y to the third? Y. In the second parentheses, we're going to do our pattern. Remember, we're going to square. We're going to change the sign. We're going to multiply. And then we're going to square the back term. So I need you to square the first term. Be careful. Not the 2 at the front, this first term. What is 2x times 2x? Well, 2 times 2 is 4. X times x is x squared. A lot of people get in a hurry and forget to square the variable. All right, we're going to change the sign. This is a minus sign, so we're going to change the sign to a plus sign. We're going to multiply. What is 2x times y? 2x times y, you just kind of squeeze it together, and that gives you 2xy. And then we need to square the back term. Remember now, anytime you square anything, anytime you square something, it will always be positive. So a negative times a negative is a positive, and then y times y is y squared. There is your factored form. Remember, always include. Now, just because you take out the greatest common factor, it is still part of your answer. Please include your greatest common factor, and then there's the factored form for the difference of two squares on this problem. All right, so we've shown you the difference of two squares, perfect squares, and then we've shown you the sum of two cubes and the difference of two cubes. That's 4 special cases that we've shown you, okay? You need to practice, do these problems on your worksheet, all right? You need to know how to do the different types of problems, and this is what the hard part is. If I can show you just one type of problem and you do it 10 times, you're really good. But when I show you 10 problems and they're all a different type of factoring, that's what confuses us. You need to practice so you'll know what type of factoring to do with each type of problem. All right? If you have questions, email us, ask questions in the Zoom, but please get help somewhere. Whether it's us or another video, please always ask questions if you get stuck. All right, good luck.